In this video, we'll be discussing slope-intercept form of a line. The equation of a line in slope-intercept form is y equals mx plus b, where m is the slope of the line and the ordered pair 0, b is the y-intercept. This is the most useful form of a line. We're able to use this form of a line to write equations of lines and graph equations of a line. Let's start by writing the equation of a line with a slope of 3/5 and a y-intercept of 0, 2. Well, we're given that the slope, which is m, is equal to 3/5, and they give us a y-intercept of 0, 2. This tells us that our b is positive 2, and now all we need to do is plug those two numbers into y equals mx plus b, and we'll have the equation of our line. We get y equals 3/5 times x plus 2. That's it. Well, now let's talk about how we can use slope-intercept form of a line to graph equations of lines. These are the steps that we're going to want to follow to accomplish that. The first thing you want to do is write the equation in slope-intercept form. To accomplish this, we're essentially just solving for y. Once we have our equation in slope-intercept form, we want to identify and plot the y-intercept. We want to then identify the slope, and from the y-intercept, we are going to apply the slope to obtain a second point on the line. And when I'm applying the slope, I want to think of slope as rise over run. So how am I going to change the y value? How am I going to change the x value? From the second point that we obtain, we want to apply the slope again to obtain a third point. We'll connect our points and have our line. So let's graph 3x plus 2y equals 8. We'll start by solving for y. We'll subtract 3x from both sides. Because I'm trying to get my equation in the form y equals mx plus b, I really want to put the x term first and the constant term second. So that gives us 2y equals negative 3x plus 8. Continuing to isolate y, we'll divide each term individually by 2. I know you have the option of dividing the whole side by 2, but you don't want to do that in this case. We want to divide each term individually by 2. We get y equals negative 3/2 x plus 4. This is our slope-intercept form. From here, we can identify the slope. The slope is always the coefficient of x. Notice that our slope is negative 3/2. This means when we graph our line, it should point down from left to right. I like to think about this ahead of time, so if my graph is not pointing down left to right, I know I've made a mistake. We can also identify the y-intercept. The y-intercept is the ordered pair 0, b, and our b value is 4. That gives us a y-intercept of 0, 4. We want to plot our y-intercept. Here it is 0, 4. And then from here, we apply our slope of negative 2/3. The change in y is in the numerator, and the change in x is in the denominator. So I need to change my y value, negative 3. So I'm going to go 3 in the negative y direction, which is down, and then 2 in the positive x direction, which is to the right, and that gives me my next point at 2, 1. I'm going to do it again. I'm going to go 3 in the negative y direction, 2 in the positive x direction, and I have a third point. These 3 points line up, so I'm going to connect my dots and draw in my line. Make sure that you put arrows at the end of your line, indicating that our line extends infinitely in both directions. Before we move on to the next example, I want to point something out about this negative slope. Remember, with fractions, when you have a negative, the negative can either be out in front or it can be in the numerator, which is how we handled it, or it could be in the denominator. Now, typically when we write fractions, we don't like the negative in the denominator, but sometimes we want to do that for graphing purposes. If we assign the negative to the bottom, starting with our y-intercept, to get another point, I would go 3 in the positive y direction, which would be up, and then 2 in the negative x direction, which would be to the left, and we'd get this point right here at -2, 7, and you see that it lines up perfectly with the other ones. So there are some times where you may choose to assign the negative to the bottom when you're graphing. Let's take a look at our next example. Let's graph 2x minus 5y equals 15. The first thing we need to do is get this in slope-intercept form. So let's solve for y. We'll subtract 2x from both sides. This gives us negative 5y equals negative 2x plus 15. Next, we divide each term individually by negative 5. We get y equals, notice that we have a negative divided by a negative. That's going to leave us with positive 2/5 x, and then a positive divided by a negative, that'll be -3. Now that we're in slope-intercept form, we can identify our slope, positive 2/5. So we're anticipating that our line points up, left to right. And our y-intercept is the ordered pair 0, b. Our b value is -3, so our y-intercept is 0, -3. Be sure that you're writing that y-intercept as an ordered pair. And y-intercept is a point. We got to use the proper notation. Now that we've identified our slope and y-intercept, we're ready to graph. We'll plot our y-intercept, which is 0, -3. And from here, we'll apply our slope, positive 2/5. So I'm going to go 2 in the positive y direction, which is up, and 5 in the positive x direction, which is to the right. And I obtain my second point at 5, -1. We'll apply the slope again. We're going to go up 2 and to the right 5. And now we can draw in our line. Before we look at our last example, I do want to point something else out about the slope here and options that we have. So we have this slope of positive 2/5. But this is the same as having -2 over -5. I mean, that's how we got this positive 2/5 in our solving process. We had a negative over a negative. So there are some times when we're graphing where we might want to turn a positive slope into a double negative slope. If we do that, starting from my y-intercept, I would go 2 in the negative y direction, which is down, and then 5 in the negative x direction, which is to the left, and we get the point -5, -5. You'll see that that point lines up perfectly with the other points in our line. Sometimes, depending on how big your graph paper is and what your slope is, you may want to do this. You don't have to, but it's just another option to help you center your graph about the y-axis. In our last example, we want to graph the line that passes through the point -4, -2, and has a slope of +3. You'll notice here they don't give us the equation of a line. They give us a point and a slope. All we need to do is plot the given point and then apply the slope to get an additional point. The only reason we ever start with the y-intercept is because it's an easy point to find. It's not special. We don't have to start there. And in fact, if we look at either of our previous examples, we had a point like here, 5, -1, that was not the y-intercept. From that point, we just applied the slope and got another point. That's essentially what we're doing here in this last example. So let's plot the point, -4, -2. And from here, apply the slope. So for the first time, we have a slope that is not a fraction. It's just a whole number. Anytime you have a slope that's not a fraction and you're graphing, you want to turn it into a fraction by simply putting it over 1. So we are going to go 3 in the positive y direction and then 1 in the positive x direction. From the point -4, 2, up 3, to the right 1. And we'll do it again. Up 3 and to the right 1. We connect our dots and have the graph of our line.